So we're going to be doing a brief introduction to our system. We have a digital interface that is very similar to this on our machines. Um, Everything is monitoring the signal feedbacks as far as the faults and the zone control if utilizing with the remote zones on the screen. You can see here that we have no ambient temperature or current steam temperature hooked up, but quite simply, if we did hook up probes into those systems there, we could monitor the temperature of whatever the live feedback may be. For instance, I'm inputting manually the values right now just to give you an indication of what it would look like, for instance. So we have 20 degrees Celsius of an ambient temperature and 11 degrees Celsius of the steam temperature. Um, what the system will do is it will monitor the steam temperature, and then it will automatically adjust the water position controls and introduce water as needed. All these variables are preset for you and logged in the manual for record keeping. Um, this is all done automatically and self-adjusts. As far as the steam generator set points go, you can have a set point for ambient if this is a containerized solution, or the steam set point to control your discharge temperature coming out of the appliance, as well as your tripping alarm temperature, cool down set point, and time limit. The time limit, as you can see, has a 30-minute cooldown up to a 120-minute maximum. This is describing the length of time that is going to be required for the appliance to run on air mode to blow out the piping after steam is no longer heated, so that everything is run dry and ready for the next startup time. The cooldown set point here, it dictates to the computer that it must maintain whatever threshold temperature is input. For instance, 100 degrees Celsius, I put in this case, it will have to maintain at least lower than 100 degrees Celsius for a period of 5 minutes, which works in parallel conjunction with the cooldown time length to actually stop the appliance at a complete stop. As you can tell here, there's an emergency stop indicated. If the input is disabled, then it will resume, and the appliance will only begin once the steam on button is initiated. Right now we can see there's also a high temperature alarm. That is because our steam temperature is currently higher than the set point temperature set on the alarm set points under machines. We're going to go here, admin 1234 is the password. Now we can adjust this, and you have a fixed range of between 150 to 200. Most clients will set this for 180. If we go back to the main, you see we still have one more high temperature alarm, and there is an external device separate from the PLC, which is our safety high limit, and that is our input on the high limit control. So if we activate the input on it, let me see here, there it is. Then now we can say that the unit is safe to start, and after a 20-second period of checking the safety interlocks of all these faults listed here, it will start the appliance up. If at any point an alarm trips, for instance max air steam, you can see the call for heat is disabled and the unit will safely do its shutdown. If a cool down is required for a remainder, there's only two instances where it will not run the blower to cool it down. One, this max air steam pressure alarm trips, meaning there is a blockage downstream of the appliance. Or two, if the emergency stop has been tripped, it will stop the blower and the motor so that no air is produced. Well, let me reset this fault and re-enable the safety interlock for the e-stop. Reset. There we go. So now everything is reset off of it. We also have several other interface measures on it. So the water tank, if you are hooking up a water tank and wanted to do thermostating, you could set a temperature on the screen for whatever temperature of water that you want to maintain. It will measure the current temperature and it will be monitored on a simple on-off thermostat. So if this temperature reaches your set point, it will heat it up to the threshold, and then it will allow it to drop a 3 degrees differential deadband, and then it will resume heat to that zone again. Um, as far as aggregates go, you can set timer thresholds and have this monitored by timer, or you can do it as a bypass, whereby if you activate the zone and you have the bypass enabled, it will produce heat on that zone until you manually deactivate it. The other part of it is if you're doing bin heating overhead, typically customers will do either thermostated or they'll do timer-based control. And the function on this is that if there is a call for heat with a timer, it will run the mode for whatever designated length that you set and then shut off. So if we don't want to thermostat it, but we know we want to throw 30 minutes of heat into it, you could set uh, you could set a value here and then reset it and then run this zone on a 30-minute timer like so. Otherwise, if you want to monitor the temperature on the bin, we would hook up a probe to this and then set a threshold temperature of whatever you may want and then turn on thermostatic mode, and it will heat up to the threshold again and then allow a 3 degrees Celsius drop. Um, all the alarm functionality and feedbacks are recorded for date and time. So when an alarm has tripped, for instance, air filter dirty, then it will record the instance of when it activated, and then it will also record the instance of when it is reset. So to reset this, reset alarm, there you go, date and time recorded. Um, Anytime there's maintenance required on it, it's recorded here. So you have your start and stop of when the motor is going to be starting and stopping. For instance, if the motor was started and running right now, then you're going to have the input recorded of when it started, and then you're going to also have the time and date when it shut off. Also, you'll see there will be recording the runtime hours on the motor, and then it will also be doing a visual inspection recording. So every 200 hours, it prompts you with a message on the screen saying there is required visual inspection just to make sure there's no oil leaks, there is no gas leaks, there's no water leaks, just a visual oversight to make sure there's nothing out of place or been tampered with. And then every 2,000 hours, it'll prompt you for an oil change on the machine. It'll actually prompt with a message just located in this area of the screen on the main. It's very easy and very visual. It's bright orange in color. Um, if there was any of these alarms that do trip, the system is equipped with a VPN, so it will prompt you with a alert by email saying that the system has tripped a fault and to review the HMI screen of how to rectify the issue. At that point, you can remotely log into the appliance from a cell phone, such as an Apple device or a PC or an iPad. Android devices at this time do not work as there's security leak with them, and the dedicated VPN provider has removed service on that. The last thing that is very important is there is these FSG safeguard faces, and what this is recording is the actual process of where the flame is in conjunction to what the machine is doing. So, for instance, off or phase 12 in this instance would be a standby mode. If it was starting the fan, it would go to phase 22. If it was in pre-purge, it would tell you phase 30, and so on and so forth. When the machine is operating as normal, it will display OP and then a percentage. Or it would display phase 60 here, and on the Siemens screen, it would show you the output percentage. The other one is the lockout codes. It does do an active lockout code history. For instance, most common ones are loss of flame signal, or a safety loop open, meaning loss of water pressure or a high temperature, it will break the flame in those instances, record it when which phase it reached, as well as a derivative diagnostic code for you so that you can essentially go in and diagnose what exactly happened. But most times they will be recorded with a generic message here that makes it easy to diagnose. The last thing that is most important is just understanding what these controls mean. So the system will start and stop itself automatically if remote zones um, are enabled based on when you do a call for heat and you have what thermostats are set up. If remote zones is turned off and you just enable steam on, it will act like a light switch to the appliance, whereby as soon as I activate this button, the machine will start up, it will start producing heat, it will ignore all the zones downstream of it, and it acts more or less like a flamethrower or a torch, where it's puts heat out and it doesn't care where the heat is going. You are responsible for manually sending it to the correct zone. Um, there is a high fire delay that you can see visually on the screen here. When high fire is enabled, it will always send it to the main flame low output first. Once the delay timer has been elapsed of 300 seconds, this modulation delayed button will illuminate saying modulation satisfied. And if you've enabled this button, it will go to the high fire state output of 100%. Only after that delay will it go to high fire. It will always sequence in pre-purge, light the pilot, low fire, and then it will go to high fire only if you've enabled this and the delay has been elapsed. If you have any more questions, please reach out to us. This is the basic operation of a steam generator.